Hello, I'm Mrs Tasker. I'm Head of Science here at Garstang Community Academy, and here we are in one of our amazing science classrooms. We've got some amazing spaces here in the science department. We have 7 teaching rooms, all equipped with gas taps and plug sockets and sinks on all our benches so that we can fit in lots of science, investigative, practical work whilst you're here. We've got an amazing team here in the science department of enthusiastic teaching staff and our amazing science technicians. We have our well-planned curriculum across Key Stage 3 and Key Stage 4 with plenty of opportunity for interesting and engaging practical hands-on work as well. We currently teach Year 7 and Year 8 at Key Stage 3, and we have a sequence of learning that includes topics such as forces, energy, particles and cells, and we have an amazing Assistant Head of Science, Mrs Kenyon, who's in charge of our Key Stage 3. Here she is with some of our students.
Right, yeah, so we're looking at a way of separating a mixture here. And in this sample here, in this pear bottom glass cake, we've got a inky mixture, so water and ink. Sadie, what do you think a mixture is?
It's a mixture like 2 or more substances that are together that aren't chemically bonded.
Perfect, okay. Well done, so they're just mixed together and they're not chemically bonded. So what I'm going to do now is I'm just heating up this substance, and this is going to allow the water in here and the ink to get hotter. Okay, so it's going to allow us to actually separate the water from the ink. Zach, can you tell me how you think it might work?
Does the Bunsen burner heat the ink and water, which then turns it into a gas, for the gas to come through the condenser and split the ink and the water?
Excellent, okay, so when you're saying it's heating up, do you think that the ink is going to boil or the water's going to boil?
No, water.
The water, why do you think that?
Because water can evaporate into a gas state and ink can't.
Okay, well, ink actually can evaporate into a gas state, but it just means that if the water evaporates first, it's got a lower boiling point than the ink has.
Yes.
Okay, so the water will rise up, like you said, condense, and then it will come into here towards the end of it. Perfect. So now we've just come back after a couple of minutes, and the water is boiling, as you can see. So the water now is moving up, sorry, the vapour is moving up into the condenser, and it is now the gas is condensing and turning into a liquid. You can see we've got quite a lot of liquid that's collected in that beaker there. So, Sadie, can you give me an example of another type of mixture we might separate using?
You could use salt and water.
Salt and water, perfect. And why would that work in the same way as this?
Because there's still water in it, which is what evaporates.
Excellent, okay, so the water's still in it and it's going to evaporate. I'm just going to turn it down just slightly so you can see it actually dripping out the end then. Just because we've seen how it works, and then we'll let it cool down and I can turn my Bunsen burner off. So can we think of another way or another substance we might be able to separate using this method? We said salt and water. We can also separate salt and water using just evaporation. Why do you think this one, Zach, might be a better idea to use this equipment rather than just standard evaporation?
Because you can take from the glass there, you can take the salt or whatever you'll mix the water with out of that one, but then you also get the water back into the beaker at the end.
So we can collect what's left over, so this in this case will be the ink,
Yeah.
and the water, so we get the both of them. And we don't get that, do we, when we're using simple just a normal evaporation. Great stuff. So that aside, guys, can I quickly ask you what you think of science at Garstang? Just your own opinion.
I like that we get to do loads of experiments and practicals to test out our new knowledge that we have.
Well, excellent. And what do you think, Zach?
I like that we're not only taught what to do, but we also get to try it out in a practical and experiment it for ourselves.
Excellent. So you get to figure out your learning for yourself rather than just being told.
Yeah.
Excellent. Well, thank you very much, guys. I appreciate your help. And we'll pack this equipment away. All done.
At GCSE, we study EdXL 9-1 sciences, and generally we have 6 classes in our GCSE year groups. We have 3 that will take combined science and 3 that will take triple science, and that's an option. We have many students here at Garstang that opt to do triple science, and often the classes are full of children who are very enthusiastic about sciences, and many go on to study science in further education and higher education as well. We teach within our specialism, so your child would be taught by biology by a biology teacher, chemistry by a chemistry teacher, and so on. And we have a history of excellent results here in our science department, year-on-year improvements to our science results, and our value-added scores are excellent. It's reflected, I think, in the students' enthusiasm for the subject and their willingness to go on and study it after they leave us here at Garstein. Here we are in Year 10 Triple Science, where our students are studying DNA extraction using strawberries. We hope you've enjoyed looking around our school virtually, and we look forward to welcoming you here in person, where we can show you around and show you everything that we do day in and day out wonderfully with our children in the classrooms.